Right, yes. What does it take to run LLVM Buildbots? First of all, I'm going to talk a bit about who Linaro is. Linaro is a company that works on open source projects, wherever those projects run on ARM, to make them the best they can be. Why am I from ARM talking about Linaro? Well, I'm assigned from ARM to work in a team in Linaro called the Toolchain Working Group. That group works on LLVM, GCC, QEMU. So for today, the point is we care about the quality of LLVM. And one of the ways we do that in the LLVM community is just to build LLVM in a lot of different ways, run a bunch of tests. So this is a bit of the universe of testing that goes on. We're just going to look at the bit in the red box. So some of you may have contributed before, you may have not. You'll have seen parts of Buildbots. Let's define what the whole system is. It's post-commit verification of changes. So we take the changes after they've gone into the LLVM project, build them, run a certain set of tests, and then if that build fails, we email everybody on the change list that went into that build with the new commits, and you get a message like you see at the bottom. And this one particular bot is just building LLDB, but they can build multiple projects, and cross over different projects. They can do 1 stage, 2 stage, whatever's important to the person who adds that bot. So this is a picture of the system. So if we start on the left, this is the only centralized bit of the system on the left. It is the build master. That's run by Galina Kistanova, and that monitors the repository for changes and then says which of the builders in the middle care about the which of the builders care about those changes. So if you only care about LLDB, it'll only signal that builder. Builder's a bit of a weird name because it's kind of a virtual view on a bunch of machines that do the actual work, and appropriately, they're called workers. So as you can see, you can have a one-to-one between a builder and a worker, or you can have a worker connect to many bots, or a single, many builders rather, or a single builder can have many workers. And the key thing for today is that those workers are provided by the community. And as Linaro, we provide a whole bunch of those for ARM. So we finished on workers. How much work are those workers going to do? We had about 33,000 commits in the last year. That breaks down to about 4 commits an hour. So the way to think about that is if your build took an hour, you're going to take in 4 commits, do the build, run all those tests. By the time you get back, there's going to be another 4 commits. So we can batch commits. So if you take 2 hours, when you come back, there'll probably be an average of 8 commits. And at that point, your bot's probably never going to be idle. You're going to be running 24/7, basically. And so Linaro contributed a bunch of these bots. We started with a 32-bit ARM Chromebook back in 2013, and now we have 29 different bots. Not going to go into that list, but I'm going to explain why there are so many. If you're not familiar with ARM, it doesn't matter. The bold text is the point here. Each one of these is a dimension of the quality aspects that we care about for LLVM and ARM. So you take all those things, you multiply them together, you get your n-dimensional testing matrix, give a hand-wavy metaphor. You cut out the bits that people have never actually built in reality, the things that aren't compatible or not compatible yet, or the things that Linaro's members don't really care about, basically. And that's how you get your 20-something bots, because we try to overlap them to give as good a coverage as we can. So we have these 20-something bots. What do we run them on? The bulk of those run on 2 Ampere Mountain Jade servers. These are 160-core ARM servers, where we run many bots per server. The largest deployment, I think, is 18 bots. Then we have 2 Surface Pro laptops, and that's where we do our Windows and ARM builds. We have a bunch of NVIDIA development boards for ARM v7, that's 32-bit ARM builds. And then finally, we have a Fujitsu FX700, which is specifically for scalable vectors, which is a new ARM extension that's important to Linaro's members. So that's a very diverse set of hardware, but as a rough measure, that's about 400 cores, 800 gig of RAM. The RAM is not so important because compilation and testing, mostly cores you want. Flang has changed us a bit recently because compiling Flang is quite expensive, but 2 gig of RAM per core is a nice average to have over your whole system. And yeah, so we talked about what we have. Let's talk a bit about how we run it. And the first big takeaway from our side in a practical sense is how you divide up those resources, divide up those machines to get the work done. But first of all, we need to define what we're actually doing. And we're actually doing 3 different things here. One is we're running that bot that's doing that build. The second is we are taking the issues that that bot finds and doing some work to narrow them down and find out what broke the build, why it broke the build. And then the third thing is you may have to do more work, do more patches yourself to make that work for your architecture, your configuration. And you have to do them in parallel, because if you slow down the bot to do any of these things, the change list gets bigger and bigger. You pile up problems, and it just gets worse and worse. So ideally, you do all these things at once. It's usually not 3 times the resources. It's something like 2.5 times the resources that you would need. So we've got a total amount of resources. How do we split that up? Well, the big lesson from Linaro is if you can, use fixed resources. So use fixed virtual machines or separate physical machines where the number of cores and the amount of RAM is fixed and never changes. Because we have tried to make good use of our big servers by dynamically allocating the resources using Docker, but this causes a lot of instability in the test suites. And if you've heard the term of Flaky Buildbot, Linaro has been very guilty of that. We're trying to do better at that in recent times. But there is a trade-off if you are trying to make optimal use of your resources, because some bots, if they are very fast, will have a lot of idle time. And everybody loves graphs, so here's at least one. And this is going to talk about that trade-off. So on the left, we have Clang Quick, which is, as the name suggests, is about a 5 to 10 minute build of Clang. And you can see that's got about 50% idle time. Because if you think back to those 4 commits an hour, you build your 4 commits in 5 minutes, and you come back. And then in the middle, you have Flang Release. Now, the Flang build is a bigger build, but it responds well to C caching, and it's a fairly niche project at this point, so it's still got a significant amount of idle time, around about 40%. And then the best case for fixed resources is if you're doing very long builds like this 2-stage build on the right, which takes about 2 hours in our configuration, and that thin red line at the top is about 1% idle time. So if you're trying to make maximum use of the hardware that you've got, you may not be able to afford the idle time, but you'll have to deal with some instability. And when it comes to Buildbots, really any instability damages the trust in your Buildbot. If you're wondering what a flaky bot looks like, this is what you might have seen. So this is a test that checks that lit can enforce a timeout onto a Google test. So therefore, that test itself has a timeout in case lit does not enforce the timeout. When your resources go up and down during the build, that test itself times out. People get that email, they stop paying attention to your bot, and I don't blame them. I do it myself. So that was a bunch of practical stuff, kind of behind the scenes resources. So let's talk more about process and how we interact with committers. And the crux here is the difference in perspective between the LLVM committer, which you can think of as the customer for the Buildbot system, and the maintainer of the Buildbot. And the basic bit here is the committer puts one commit into the repo, it goes into one build. If it fails, and only if it fails, they get an email that says, failed this build. But you as the maintainer see everything. And it can be tempting to say, I don't have a flaky bot because it's only 1 in 100. But the committer's the customer, they see one build, it's flaky, you have a flaky bot. To expand on that a little bit, there are some kind of facts of the situation that you need to keep in mind. We covered the first one. The committer's usually unaware that your target existed. until now. They often don't know the architectural details of your target or your configuration. They are less incentivized than you to fix the issue, although the gap is a lot smaller than you think, but it's still there. And they're often unable to access your hardware, which is probably why you started a bot in the first place. But like I said, these are facts of the situation. I don't think they're good or bad. The way we handle those is the good or bad bit. So we've developed this approach at Linaro, which starts out with remembering that these failure emails come out of the blue. And at the best, they're neutral news, because a lot of people who are regular committers kind of expect a few emails. But generally, they're bad, because they're interrupts, basically. So when we're talking to committers, we want to not make any assumptions. And that goes both ways. Don't assume that they are experts. Don't assume that they know nothing. Essentially, give the same help you would to someone you know is an expert to somebody you've never seen before. Proactively notify the committers as well. Have a conversation with them, even if it's just to make a contact. Maybe they saw the email and they already know what to do. But at least you can thank them for doing the fix and being prompt. And if they need extra help, then it's easier for them to respond in Fabricator rather than email, which is kind of disconnected from that system. Cover the Flaky bot stuff. It's harsh but true, but as a maintainer, you have to accept that. Be ready to work with the committer, as I said, provide them information, test fixes. But also, there are situations where you're just going to have to take it upon yourself to do that fix. And you have to be prepared with some spare time to be able to do that. So how are we going to find these issues? The overarching thing here is monitoring. And the simplest way to do that, if you have a single bot, is to add yourself to the email notifications. And what that means is when a build fails, it'll email everybody on that commit list, plus you as the maintainer. So that's a nice interrupt-based way of seeing that there's an issue. You can also just pin the web interface for your bot in a web browser. It's very glanceable, green to red. You know something needs to be done. If you have a whole bunch of bots like we do, the API is quite easy to use, and you can build a status page. You can even copy ours if you like. It's MIT licensed. You can go download it. And the final thing I'd say about monitoring is it's got a lot of upsides. You make a lot of contacts. You kind of travel around the project, build some experience. But it can be quite exhausting. So keep it to about a week rota and rotate it around your team and around your community to spread the benefits and the drawbacks. So you've done your monitoring. You found an issue. We're going to do what we call triage. And the key here is the first thing you want to know is what broke the build, not why. You might stumble upon the why when you find the what, but the what is the immediate thing. And a couple of strategies to do this is, one is to look at the different categories. So if you run a 32-bit bot, have a list you know of all the other 32-bit bots. See if they're all affected. And then what you can do is take the common changes from those builds and then either just pick the one that it obviously is, or make a small change list so you can do a bisect. And bisect is the real hero here, especially as we're in a monorepo now. Committers don't tend to argue with a bisect. They may argue why their change did break the build, but the question of whether it was their change or not doesn't really come up. Bisect ends that conversation, basically. And then finally, reverts. So I wrote my own version of this, and I thought it was going to be a hot take. But somebody said, have you actually read the developer policy? And I had to admit that I had not read the developer policy. So I'm just going to quote one line here. Remember, it is normal and healthy to have patches reverted. And that's basically what I believe, and I'm glad to see it's in the policy. I should have read it, but hey. The policy is great, but it's not fully embraced. But I don't think that's because people don't want to embrace it. I think it's because it requires a certain amount of psychological safety to take something like a revert, which is inherently has a meaning of going backwards, and look at it as a neutral thing, or even a positive thing, because you're doing interesting code changes that have wide-ranging effects. So for those of us who have managed to embrace it some, I think it's on us to lean into that more and create that safety for other people to really lean into this. So live by that and set the example. Repeat it every opportunity, like this one. And wherever we can, make reverts less surprising. So anybody new to the project, make sure they're aware of the whole life cycle of a commit. So we don't get this, I worked on it for 2 weeks and it got reverted in 10 minutes. What did I do? So final section is some conclusions about the system overall. I'm going to start off with the bad. And this one is a bit inside baseball. It's more for maintainers than for committers. But if you have a bot that's triggered on the LVM project, but it runs the LVM test suite, which is a separate repository, you'll only see the changes for the LVM project. And there are situations when new tests are added, and you have to kind of have an intuition of what that bot is doing to know what's gone wrong. And it's also means that it's not quite a simple bisect. Something like Jenkins gets this right. Buildbot has this limitation of being around one repository. The next thing is that when you need to change the configuration of your bot, that requires a build master restart before those configuration changes actually get to your worker. There are some good reasons for that, because you can potentially damage other people's configurations when you do that. So I'm sure there are good software decisions. And it is quite easy to ask for a restart from Galena, which will schedule one. But it'd be nice if there was some way we could more quickly do these configuration changes. And the final one is that every builder builds every commit, even if the most normal builder has said, this is going to fail everywhere. And we're going to talk about more of that in the final slides. So the good, the LVM community. And that sounds trite, and of course I would say this here, but I think the system works as well as it does because people are willing to work with each other. And they do, as I mentioned, there is a gap between, say, my motivation as an ARM employee to fix an ARM build issue and somebody who's an AMD employee. But that gap is actually really, really small. And we've never had a problem with any committer, ever, really, in LVM. So maybe not a good of Buildbot, but a good way of interacting with Buildbot. As I mentioned, bisecting is great, and it's so much easier now that we're in a monorepo. And this one is specific to Buildbot, is at the web interface. I mentioned Jenkins earlier. Jenkins tends to give you all the information in the most ugly way possible. And Buildbot gives you a minimal amount of information in a fairly clean way. So you might get annoyed that something's not there, but at least it's not cluttering up the interface. And the key thing for me as a maintainer is it's easy to just with a mouse click, go to the change list, go to GitHub, click on our link to Fabricator, and then leave a comment. And finally, the future. There's a whole bunch of ideas here, but I'm going to go with one. Short term, I would like to see a lot more. We either want to lean into the pre-commit builds that are going on in Fabricator or rethink what we're doing there, because they have been doing some of this, but with great difficulty, and people are confused as to whether they should pay attention to them and how important they are and what the future direction is. I have people in ARM asking me, is LVM going towards pre-commit? Is this the big new thing? I say, well, I'd like it to be. But, and the obvious thing there, pre-commit, you catch the issues early. It's less surprising for committers. Long term, and this is maybe the hot take that I replace the reverts with, let's move all the bots to pre-commit with some asterisks there for niche stuff. But basically, this would mean no surprises for committers. Everything would happen within the review interface. You wouldn't have reverts, you wouldn't have relands. Okay, we'd have to come in and explain some failures, but it's all captured within that review interface, which is probably going to be GitHub. This is very similar to Rust's model, where main is always green. For you to land a patch, it has to pass at least the tier 1 targets. And it sounds like a big thing, big model change, but libc++ has already done this. That's on the right. And since they've switched, Linaro has had to do absolutely zero maintenance on that stuff. The community has done it all. We just provide the machines. Big question there is, what is the cost multiplier? How many more builds and pre-commit? So before any of this can be taken seriously, I need to do some work, work out what that multiplier is and what the dollar multiplier is on that, especially for Linaro. So with that was my talk. Thank you for listening.
Thank you, David, for a great talk. It was very informative. I've really enjoyed this. We have 5 minutes for questions, and we have 2 microphones over there. Yeah, go ahead.
Hello, thank you for this presentation. It's enlightening, where you share your experiences. I have a question to you as a Linaro team member. How does Linaro decide which projects to build on Buildbot?
So Linaro has member companies, one of which is ARM, Fujitsu is one, and they essentially will vote for initiatives. So an initiative might be we care about LLDB, or we care about scalable vectors, or we care about 32-bit ARM. And as those priorities change, we bring up and down Buildbots. We'll get special requests. SVE was one of those to do certain validation on those. So it's really what our members think, and then a bit of what we think is healthy for the ecosystem as well.
Thanks also for the talk. My question is regarding Buildbots running either incremental builds, Zcash builds, or full builds. What's your take on that?
We use Zcaching a lot, like on our servers with the 18 to 20 bots. They all share a Zcash volume between them, which sounds quite dangerous, but you can get away with it. I'm not sure how much effect it has on the Clang and LVM builds, but I know that if you have a large cache, a Zcash, Flang responds quite well for that, which is good because the initial Flang build time is very long, lots of RAM, but the rebuilds after Zcaching is good. So Zcash is what we've primarily used.
And incremental builds?
We have not investigated incremental builds.
Thanks.
I have another question if there's nobody else. So to deal with the issue with the Buildbot master restart, I've noticed that some of the builders are moving towards using the annotator protocol, where like you start a script which is then emitting the extra annotations, and those are read by the Buildbot configuration. And so then all you have to do is change the script, land the commit, and the change is immediately picked up. I know that this is used, for example, by the sanitizer bots. Do you think that we should be moving towards a model for other builders as well? Is this something that's being actively discussed?
I hadn't actually thought about that, but now you mention it, that's how libc++ works. So yes, keep your Buildbot CI configuration in the same repository as the thing that you're building, ideally. Because what I didn't mention is that configuration repository is called LLVM Zorg for reasons I don't understand. It's a separate repository, so there's a separate thing going on there. And the other cool side effect of keeping your bot configuration in the same repository as the source code for like in libc++ is you can check a change to the pre-commit configuration in pre-commit. So before you even land that, you know that you're not breaking anybody else. So yeah, that's a really good thing to investigate, I think.
I feel like Buildbots web UI getting slower and slower. Is it my personal impression? Or?
Some days it's slower than others. It seems to go up and down. I've seen it show like weirdly old cache results. If you go to the builder page, it'll be builds from like a day ago. And then if you go into a build and click next a bunch, you get to the new one. So I don't know. I don't have a perspective. It'd be really interesting to hear Galina's perspective running the bot and how much resource that takes. But yeah, it tends to vary day to day.
Thanks for the talk. So an interesting model that I've seen in some other open source projects is the idea of a commit bot where commits cannot go in, like individual commit authors are not able to commit to the repository. Instead, you have a bot, and the bot guarantees that pre-submit tests have run to completion, and maybe that the patch has also been accepted by code reviewers, and then things get purged. I guess, has anyone expressed any interest in that? Is that something we're not interested in?
It's something I'm interested in just because it would cut out a bunch of work for Linaro and it would cut out a bunch of surprises for committers as well.
Yeah. So I feel like you probably can move, like probably need to do a lot less post-submit testing if you front load the pre-submit testing. It will add latency to when commits go in, but Is there really a need to be able to commit things that flexibly, or can we defer it to a bot? I get very nervous when I see how many people have commit access. And for the record, I swear that's going to turn into a disaster someday.
I think there's a lot that we can move into pre-commit. I mean, libc++, for example, there are still post-commit builds that build libc++ as part of an integration thing. So you have the kind of tiered aspect that Rust has. So yes, I mean, I have interest in doing this. I think there's some appetite from the Google libc team. They've been doing some pre-commit CI stuff. And yeah, I hope that in a non-fabricated world, it's less painful to do that integration. So.
Thanks.
Okay, thank you again, David. Thank you for coming. We are now going to break.